Hello students and good morning. So now I am doing class for class 12. The topic is second order derivative. So in the last online class also we were doing some problems on second order derivative. So today we will continue the problems on second order derivative. Okay. So exercise 4, this is 4 marks section and page number 321 from the book Higher Mathematics for class 12 by XII, right? So let's start from question number 10, number 2. So if cos x is equal to y cos of a plus x, then you have to prove that d2y by dx square is equal to 2 sine a sec square within bracket a plus x into tan of a plus x. So from given you have to prove the value for d2y by dx square. Okay. So now given, so what is given here? Cos x is equal to y cos of a plus x. Since you have to prove d2y by dx square in terms of x, you have to express y in terms of x. In order to prove the value for d2y by dx square in terms of x, you have to get the value for y in terms of x. Is that clear? So, or what is the value for y here? This is cos x divided by cos of a plus x. Is that understood? So we have got the value for y, which is equal to cos x divided by cos of a plus x. So now let us find out dy by dx. That means you differentiate both the sides with respect to x. So differentiating both the sides. So differentiating both the sides with respect to x. Okay. So this is your dy by dx is equal. You can use u by v rule here. U by v, you know that, isn't it? So denominator remains same. That is cos of a plus x into. Now differentiate the numerator with respect to x. It is minus sine x. Then comes minus sine. Now keep the numerator as it is, that is cos x into. Now take the differentiation of the denominator. What is the differentiation of the denominator? It is minus sine of a plus x into 1. How did you get that 1? You have to differentiate a plus x with respect to x, which is equal to 0 plus 1, which is equal to 1. So sine of a plus x into 1 is sine of a plus x. So that's why we did not write 1 out here. Okay. So whole divided by, you know that whole divided by denominator whole square. What is denominator whole square here? That is cos of a plus x whole square. I think you have understood it. So or this is your dy by dx. Now let us simplify it further. Let us write down plus sign first. Minus to minus plus. That is sine of a plus x into cos x. Right? Then minus into plus is minus. Then write down first cos of a plus x. Then you can write sine x. So whole divided by. What is denominator whole square? This is your cos square a plus x. Is it clear to all of you? So now you can use the formula in the numerator. So what is the formula in the numerator? This is sine a cos b minus cos a sine b. So a plus x is taken as a and x is taken as b. So it becomes sine a cos b minus cos a sine b. What is the formula? Sine of a minus b. Is that clear? So let us write down the formula here. So dy by dx is equal to, in the numerator, what is the formula? This formula is from compound angle, that is sine of a minus b. So sine of what is a? A plus x minus b. What is minus b? Minus x. This whole divided by cos square a plus x. Cos square a plus x. Is that clear? So here x gets cancels. So or what is dy by dx now? So it is dy by dx is equal to sine a divided by cos square a plus x. So I think you have understood it. So we have got the value for dy by dx. Now again you have to differentiate it to get the value for d square y by dx square. Okay. So before that, since sine a is constant, which is the numerator, and the variable is in the denominator. So you know that 1 by cos square means sec square, isn't it? 1 by cos is sec. So what is 1 by cos square? It is sec square. So you can write it in the numerator as, so dy by dx is equal to sine a into, this is your sec square a plus x. So you first of all make it sec square a plus x. Now you can differentiate both the sides with respect to x. Okay. So now let us write here differentiating both the sides with respect to x. So therefore differentiating both the sides with respect to x. So now dy by dx becomes d2y by dx square is equal to, since sine a is constant here, sine a remains same, sine a into, now differentiate sec square a plus x. You have to differentiate sec square a plus x. First of all, it is in the form x square. This sec of a plus x is the variable. Let us take it as x square form. What is the differentiation of x square? It is 2x. But you should write 2 sec within bracket a plus x into. Again differentiate the term which is assumed as x. Yeah, x kela maneko sec of a plus x. Now sec of a plus x la hami feri differentiate gardaisau, taking it as sec x. What is the differentiation of sec x? Sec x tan x. But here sec of a plus x into tan of a plus x into, again a plus x लाई हामीले x लेको हो, त a plus x लाई फेरि डिफरेन्शिएट गर्दा कति हुन्छ? 0 plus 1. That is your 1 into 1, right? So here you can write into 1. Is that clear now? So let's simplify it. Or this is your d2y by dx square is equal to, now 2, write down 2 first, then write down sine a into sec is sec square, that is your sec square a plus x into, then tan of a plus x into 1 is tan of a plus x. So is it proved now? It is 2 sine a sec square a plus x tan of a plus x. So which is equal to right hand side. So that is proved. Is that understood now? So you can copy it. Now we'll do the next problem. So now we'll do the next question, that is question number 11. If y is equal to sine of log x, prove that x square y2 plus x y1 plus y is equal to 0. So from given, you prove the relation between y1, y2 and y. The given but I mean direct your relation I mean prove gonna सक्छौं. So let us write down given here. Here given is y is equal to sine of log x. Let us find out dy by dx first. So differentiating both the sides with respect to x. So therefore it is dy by dx is equal to, now you can take it as sine x form. Log x is taken as x. What is the differentiation of sine x? Cos x. So it is cos of log x. Again you have to differentiate the term which is assumed as x. So in this case log x is assumed as x. So what is the differentiation of log x? It is 1 upon x. Okay. So पहिला हामी के गर्छौं, अब यसलाई फेरि हामी, you have to differentiate it. Before that cross multiply by x here, or x into dy by dx is equal to cos of log x. Is that clear now? Now again you have to differentiate both the sides with respect to x, because you have to find out the second order derivative which is y2. So now again differentiating both the sides, with respect to x. Therefore, so you have to use UV rule here. Both are the variables. So now you know UV rule, isn't it, or product rule. X is kept as it is. Differentiate dy by dx with respect to x, d2y by dx square plus Now differentiate x, keeping dy by dx as it is. What is the differentiation of x? 1. What is the differentiation of x? That is 1, and dy by dx is kept as it is, which is equal to. Now we have to differentiate right hand side also. So this is the form cos x. What is the differentiation of cos x? Minus sine of log x into, again differentiate log x with respect to x, which is equal to 1 upon x. I think you have understood it. Now cross multiply by x here now. So x into x, x square, it is d2y by dx square. Then plus x cross multiply, the second term becomes plus x dy by dx is equal to, on the right hand side, minus actually what is sine of log x? Sine of log x is y, so it is minus y. Okay, so minus y, take it to the left hand side. So or x square into d2y by dx square plus x into dy by dx plus y, which is equal to 0. Is that understood? So this is the answer actually, but in the question it is given as y1 and y2. So question ma jasto दिएको छ त्यस्तै निकाल्ने यहाँ पनि, ठीक छ? So or x square, what is d2y by dx square? Y2 plus x, what is dy by dx? That is your y1 plus y is equal to 0. So which is the given relation? That is proved. So I think you have understood it. So you can copy it. This is also important question. So now we'll do the next question, that is question number 12. If log y is equal to sine inverse x, prove that within bracket 1 minus x square into d2y by dx square is equal to x dy by dx plus y. So from given you have to prove directly the given relation. Okay, so let's start. So given log y is equal to sine inverse x. So first of all, let us find out dy by dx. That is, you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x, right? So therefore, what is the differentiation of log y with respect to x? It will be, first of all, it is in the form log x. What is the differentiation of log x? 1 by x. But instead of x there is y, so it is 1 by y into, again differentiate the term which is assumed as x. In this case this y was assumed as x, so what is this differentiation with respect to x? It is dy by dx. Now differentiate sine inverse x with respect to x. What is the formula? It is 1 upon root over 1 minus x square. Is that clear? So now before differentiation you can cross multiply, you can do cross multiplication. Okay, so or this is your root over 1 minus x square into dy by dx, which is equal to y. Is that clear to all of you? So we got this relation, that is we got the value for actually dy by dx, but in this case we have cross multiplied. So if you do cross multiply, it will be easier for you to differentiate it again. So now if you remove that square root, it will be easier for you to simplify it. Okay, so if you square both the sides, what do we get? Write down squaring both the sides. Squaring both the sides. If you square both the sides, from here square root will be removed. So it is 1 minus x square into, this is your dy by dx whole square is equal to y square. So square root is eliminated from the left hand side by squaring both the sides. Okay, and squaring of dy by dx, it is dy by dx whole square. Now you can differentiate both the sides with respect to x. So here you should write differentiating both the sides with respect to x. Okay, so now you can use your UV rule. You know what is UV rule, isn't it? So product rule use garda feri. Now 1 minus x square is kept as it is. Now differentiate dy by dx whole square. How will you differentiate it? It is just like your x square. Dy by dx is the variable, so it is taken as x square. What is the differentiation of x square? 2x, but here it is 2 into dy by dx into, again differentiate dy by dx with respect to x. So what is this differentiation? It is d2y by dx square. Then write down plus sign. Because this is the UV rule, so you have to write down plus sign. Now dy by dx whole square is kept as it is. Now differentiate 1 minus x square with respect to x. For 1 it is 0, for minus x square it is minus 2x into, now which function is kept as it is? Dy by dx whole square. So it is dy by dx whole square, which is equal to, now differentiate right hand side with respect to x. So it is 2y into dy by dx. So I think you have understood it. So now you can take common from the left hand side. So what is common from the left hand side? 2 is common, and this dy by dx whole square means dy by dx into dy by dx. So 2 into dy by dx is taken common. So 2 into dy by dx is taken common. So within second bracket, what do we have? 1 minus x square into d2y by dx square, plus into minus. Now you should write x into dy by dx. X into dy by dx, second bracket is closed, which is equal to, on the right hand side, it is 2y into dy by dx. So I think you have understood it. From both the sides you can cancel this 2 dy by dx, as dy by dx not equal to 0. Since dy by dx not equal to 0, so you can cancel them. Okay, so what are the remaining terms now? It is 1 minus x square into d2y by dx square minus x dy by dx, which is equal to y. But in the question, this minus x into dy by dx is taken to the right hand side. So let us take it to the right hand side now. So, or it is 1 minus x square into d2y by dx square, which is equal to, on the right hand side, x into dy by dx plus y. So this is the final answer. So it is proved. So I think you have understood it. This question is also very, very important. So now we'll do the next question now. So now we'll do the next question, that is question number 13. If y is equal to cos of cos x is given, you have to prove that y2 minus y1 cot x plus y sin square x is equal to 0. So as you know that y1 is dy by dx and y2 is d2y by dx square. Now let us differentiate this given to get dy by dx first. Okay, so here given is y is equal to cos of cos x. So let us take its differentiation. So differentiating both the sides with respect to x. So therefore dy by dx is equal to, this is in the form cos x. Which function is taken as x? Cos x. So this is your cos x. What is the differentiation of cos x? It is minus sin x. Minus sine of, what is x here? It is cos x into, again differentiate the term which is assumed as x, that is cos x is again differentiated. So what is the differentiation of cos x? Minus sine x. Okay, so or dy by dx is equal, this is minus into minus plus, you first write down this sine x first, then sine of cos x. Is that clear to all of you? Now again you have to differentiate it. Again differentiate both the sides with respect to x to get d2y by dx square. So differentiating both the sides differentiating both the sides with respect to x. So this dy by dx becomes now d2y by dx square, and on the right hand side you can use UV rule. So you know UV rule, product rule, isn't it? Now sin x is kept as it is into, now differentiate sine of cos x, you can take it as sin x to differentiate it. So its differentiation is cos of cos x into, again differentiate cos x with respect to x, that is your minus sin x. Is that clear? Then plus, what will you write now? Now keeping sine of cos x as it is, differentiate sin x with respect to x. What is it? It is cos x. Cos x into sine of cos x is kept as it is. Is that clear now? So let us simplify it again. So, or this is your d2y by dx square, which is equal to, now this becomes plus into minus is minus. This is your sin x into sin x is sin square x. Sin square x into, then write down cos of cos x. This is your cos of cos x. Now here plus cos x into, now this cos x is kept as it is. Now what is sine of cos x? Now let us mark it as number 1. So from number 1 you can get the value for sine of cos x. What is the value for sine of cos x? From here this sine x is taken to the left hand side, it becomes 1 by sine x into dy by dx. That is the value for what? It is sine of cos x. So from 1, what is the value for sine of cos x? It is 1 by sine x into dy by dx. So we can put the value for sine of cos x out here. Okay, so what is the value for sine of cos x? Your sine of cos x value number 1 but ke rahecha 1 upon sine x, 1 upon sine x into 1 upon sine x into dy by dx. This is your dy by dx. So I think you have understood it. Okay, so or d2y by dx square, d2y by dx square is equal to minus sine square x is kept as it is into, now what can you put for cos of cos x? So what will you substitute for cos of cos x? Cos of cos x is equal to y. Y plus, what is cos x by sin x? It is cot x into dy by dx. So I think you have understood it. Now take all the terms to the left hand side to make right hand side 0. So or it is d2y by dx square minus this cot x dy by dx becomes minus on the left hand side, and this minus sign becomes plus sin square x into y, which is equal to 0. So you can replace d2y by dx square by y2 minus, what is dy by dx? Let us write it first. What is dy by dx? y1 into cot x plus, let us write down first y, then write down sin square x, which is equal to 0. So it is proved. That is, we proved that y2 minus y1 cot x plus y sin square x is equal to 0. So we have proved this relation. Okay, so let us write here proved. So is that understood now? So now we'll do the next question. So now this question number 14 number 1 is your homework. So you can do it at home. 14 number 1 is your homework. If y is equal to sin inverse x, then you have to prove that 1 minus x square into y2 minus x y1 is equal to 0. That is your homework. Okay. So now let's do here 14 number 2. What is given? If y is equal to sin inverse x divided by root over 1 minus x square, you have to show that 1 minus x square into d2y by dx square minus 3x dy by dx minus y is equal to 0. You have to prove this relation from given. So first of all you have to find out dy by dx. So here given is y is equal to sin inverse x divided by root over 1 minus x square. Now before differentiation, you cross multiply it. So, or this is your y root over 1 minus x square is equal to, this is your sine inverse x. Now you differentiate both the sides with respect to x. So, differentiating both the sides with respect to x. So, you know, you have to use UV rule or product rule. So first you differentiate y keeping root over 1 minus x square as it is. So what is the differentiation of y with respect to x? It is dy by dx root over 1 minus x square plus. Now y is kept as it is. Now differentiate root over 1 minus x square. What is this differentiation? 1 upon 2 root over 1 minus x square into. Now again differentiate the term which is on the square root. तो यो स्क्वायर रुट भित्रकोलाई हामीले x लिएर डिफरेन्शिएट गरेको हो नि त. सो 1 माइनस x स्क्वायर को डिफरेन्शिएसन अब कति हुन्छ -2x. इज दैट क्लियर? सो व्हिच इज इक्वल टु ऑन द राइट हैंड साइड व्हाट इज द डिफरेन्शिएसन अफ sin इनवर्स x? अगेन इट इज 1 बाय रूट ओवर 1 माइनस x स्क्वायर. I think you have understood it. So here you can cancel this 2 gets cancels, or dy by dx it is root over 1 minus x square plus or minus. This is your minus sign. This is your minus sign. X into y. xy divided by root over 1 minus x square, which is equal to 1 upon root over 1 minus x square. So I think you have understood it. Now you have to simplify it first and then differentiate. Now cross multiply. Now here you can cross multiply by this root over, isn't it? So, or if you cross multiply it, root over into root over, square will be removed. You will get 1 minus x square, 1 minus x square into dy by dx, right? Into dy by dx, then minus xy by root over 1 minus x square into cross multiply by root over 1 minus x square. Here root over 1 minus x square will be cancelled here. So you will have only minus xy. So which is equal to, on the right hand side, what is there? It is 1. So it is cross multiplied. Is that clear? Now again you have to differentiate both the sides with respect to x. So again differentiating both the sides with respect to x. I'm फेरि यसलाई differentiate गरौँ. So what do we get? You can use UV rule here because this is the product of two functions. So 1 minus x square is kept as it is. Now differentiate dy by dx with respect to x. It is d2y by dx square plus. Now differentiate 1 minus x square with respect to x. For 1 it is 0 and for minus x square it is minus 2x into dy by dx is kept as it is. Okay. Then minus. Now write down within second bracket. Since minus sign is there, you have to use product rule for xy. So minus, so within second bracket use product rule for xy. Now x is kept as it is. Differentiate y with respect to x, dy by dx. As there is no space there, I'll write it in the next step. So plus, now take the differentiation of x, keeping y as it is. X co differentiation 1, so 1 into y is y. Is that clear? So which is equal to, what is the differentiation of 1? Which is equal to 0. Is that clear? Actually this is the continuation line, right? The xy लाई हामीले कसरी differentiate गर्यौं? X is kept as it is. Take the differentiation of y dy by dx plus sign. Now keeping y as it is, take the differentiation of x. What is the differentiation of x with respect to x? That is 1 into y is kept as it is. That is 1 into y is y. So second bracket is closed, which is equal to 0. Now let's simplify it now. Or this is your 1 minus x square into d2y by dx square, right? So plus and minus is minus 2x dy by dx. Now multiply by minus sign to open the bracket. So minus x dy by dx, right? So minus into plus, minus y, which is equal to 0. Is that clear? Now let's simplify it again. Or 1 minus x square into d2y by dx square. Okay, so now these are two similar terms, minus minus, same sign, you can add them. Minus 3x into dy by dx, right? Minus 2x dy by dx minus x dy by dx, that is your minus 3x dy by dx. Then minus y is there, which is equal to 0. That is proved. So we have proved the required result. So it is proved. So this question is also very, very important. This 14 number 2. So 14 number 1 will be your homework, right? So now we'll do the next question now. So now we'll do the next question, that is 14 number 3. If x is equal to a plus bt bracket close, then e to the power minus nt, so that d2x by dt square plus 2n dx by dt plus n square x is equal to 0. So you have to prove this relation, which is in terms of second order derivative. So in this case, which are the two variables? Since you have to get dx by dt and d2x by dt square, so here x and t are the variables. यसमा x र t चाहिँ भेरिएबल, अरु सबै चाहिँ के हुन्छ constant. That means constant भने कुन कुन भयो? a, b र n चाहिँ constant, x and t are the two variables. Okay, so here given is x is equal to a plus bt into e to the power minus nt. Now differentiating both the sides with respect to t, let us differentiate both the sides with respect to t, right? So therefore this is dx by dt is equal to, now a plus bt, since t is there, this is the variable, e to the power minus nt, t is there, this is the variable. So you have to use uv rule or product rule. Okay, so a plus bt is kept as it is into, now differentiate e to the power minus nt with respect to t. What is it? E to the power minus nt into minus n. Again differentiate minus nt with respect to t, which is equal to minus n. Now plus, now keeping e to the power minus nt as it is, take the differentiation of a plus bt. For a it is 0, plus for bt it is b into 1, that is only b, plus b e to the power minus nt. Is that clear now? So, or now let us simplify it. Dx by dt is equal to, minus n is written first here, so minus n is taken outside, so it is a plus bt into e to the power minus nt plus b e to the power minus nt. Is that clear? So now instead of a plus bt into e to the power minus nt, you can write it. What will you write it for this one? You can write x. Instead of this expression, you can write x here. So or dx by dt is equal to minus nx plus, because you know that a plus bt into e to the power minus nt is x, isn't it? So this will be minus n into, minus n is already there, minus n into x plus b e to the power minus nt is kept as it is. Okay, now minus nx, take it to the left hand side. So it is dx by dt plus nx is equal to b e to the power minus nt. Is that clear to all of you? So let us mark it as 1, because we may use the value of b e to the power minus nt. That's why it is marked as number 1. Okay, now again differentiate both the sides with respect to t. Again differentiating both the sides, with respect to t. So फेरि हामी differentiate गरौँ. So let us differentiate both the sides with respect to t. Now what is the differentiation of dx by dt with respect to t? Again it is d2x by dt square, right? Then plus, here n is constant, remains as it is. Differentiate x with respect to t. It is dx by dt, which is equal to, on the right hand side, b is constant, remains same. Now differentiate e to the power minus nt with respect to t. First of all, it is e to the power minus nt into, again differentiate the term which is assumed as t. पहिला हामीले यसलाई e to the power t लिएर differentiate गर्यौं. E to the power t को differentiation e to the power t, but here instead of t you have to write minus nt. Again differentiate the term which is assumed as t, that is you have to differentiate minus nt with respect to t. The into कति हुन्छ? Minus n into minus n. Minus nt को differentiation with respect to t कति हुन्छ? Minus n into d by dt of t, which is equal to 1. Okay, so or now it is d2x by dt square plus n into dx by dt is equal to, right, minus n first. Minus n is written first. Then what is the value for b e to the power minus nt from 1? What is the value for b e to the power minus nt? It is dx by dt plus nx. So instead of b e to the power minus nt, you can write dx by dt plus nx. So within bracket dx by dt plus, what is the value for b e to the power minus nt? It is dx by dt plus nx plus nx. Is that clear now? So let's simplify it now. Or d square x by dt square plus n into dx by dt is equal to, now multiply by minus n here, minus n into dx by dt, minus into plus, minus n into nx कति भयो? It is n square x. Now let us take all the terms on the right hand side to the left hand side, so that you have to make this right hand side 0. So or what do we get? d2x by dt square. Now 2n dx by dt is there. So what is plus n into dx by dt? Minus becomes plus on the left hand side, plus n into dx by dt. What is it? Plus 2n into dx by dt. Right? Then minus n square x, it becomes plus on the left hand side. So it is plus n square x, which is equal to 0. So it is proved. So I think you have understood it. So we have proved the required result. Okay. So this much is for today. So you revise all the problems that we did today, and I also gave you some homework. You do that homework. Okay. So in the next class we'll do more problems on this second order derivative. Okay.